a new solar energy project in the Tanga Desert of China. It's set to become one of the world's largest and will supply over 2 million homes with electricity.
In China as elsewhere, renewable energy is becoming lower cost solution than fossil fuel.
The port of Aalborg, Denmark. Blades are being loaded for an offshore wind park in the North Sea.
For me, the blade is beautiful. It's a symbol of green energy.
Right now, the world is going through its greatest transformation since industrialization 150 years ago. To beat climate change, fossil fuels will need to be phased out for renewable energy. But is that even possible? And if it is, what do we need to do to successfully make it happen? It looks a bit like giants performing a dance routine. These rotor blades are among the largest in the world. Soon they'll be turning to the coastal winds of Denmark's North Sea, providing energy from a source that can never run out. Aalborg is a key location for the transition in energy production. Engineer Eva Nielsen is helping make this transition possible.
I remember my first time I saw a blade moving. It was lifted from the mold and it was moving under the roof. I imagined that it was like Star Wars, a ship just moving above me because it was so huge. And that was a 75-meter long blade, and now we have 115 meters. I still get impressed when I go in production halls and I see at the other end of the hall, several hundred of meters away, I can see small people.
Up to 18,000 households can be supplied with energy from a turbine of this size. Here in Aalborg, German-Spanish manufacturer Siemens Gamesa is building some of the largest wind turbines in the world. In the future, however, it won't just be about building as big as possible.
I believe in the future there will be much more focus on the waste. Our customer will come with demands, and the demands will come into the contracts that we have to improve ourselves over the time. So that will be now it's a big news that we can make recyclable blades, but over the time that will be something that we will need to do because we have to improve the way we are building.
Currently, the fiberglass composite blades can't be recycled. By 2030, though, all rotor blades made in Aalborg are to be fully recyclable.
What we have a form where we put all the materials into the form. And once we're finished, we close the form and then we put epoxy. So the epoxy, it combines all the materials and all the components together. And then we bake it. We bake it like a cake. When we're finished baking, we open up the mold and then we have the blade.
It'll be even more important in the future that wind turbines can be recycled at the end of their service life as we build ever more of them offshore on the open seas. Where today there are thousands, there will soon be tens of thousands.
For me, it's like a symbol of pure energy. If you have a blade, this is a slice of a blade. The aerodynamics of it, this is what you see from the outside. This is what most people see when they look at the turbines. But as an engineer, I also look at the inside, where we have the strength, where we have the reinforcement. So it's super interesting and it's really, really nice.
The high-end technology has been good for growth. Over 20 years, the plant at Aalborg has expanded to provide around 700 jobs. Sarah Machi was offered hers while she was still studying.
What's really interesting is that when you have this great product that you produce here, you have a lot of other industries that kind of follow that. So that means that when we make blades, you need someone who tests them, you need actually sustainable ways to transport it. So you had a lot of growing together when you actually start out with a project like this. To see what I'm working with in its physical form and knowing that I was able to help make this, that's insanely gratifying, and it really gives a lot of joy in my life, and that's invaluable.
Denmark is a pioneer in the field of wind energy and a global leader in the transition to a carbon-neutral economy. Lena Barford is the deputy mayor of Copenhagen, addressing the issues of technology and the environment.
When I was a kid, in the start of the 70s, we were hit by the oil crisis, like a lot of other countries. And of course, a lot of political resources were put into how can we reduce the energy consumption. But also a lot of people in Copenhagen, in Denmark, started to say, we want to produce energy that we can be sure of. So a lot of people started to look at wind and solar power.
Wind power covers over half of Denmark's usage, the highest per capita in the world. Mads Nippa is CEO of Ørsted, builder of offshore wind farms.
The way I would see the global race against time to fight climate change is that there is no competition. There are only partners on the green transformation. And we need to help each other. We need to share all technology innovation we have across the world with each other, not make it proprietary, because if one small country invents great solutions and it only helps a small country, then it won't help the world.
And the rest of Europe benefits hugely from Denmark's know-how in wind energy too. While in Denmark, wind power already makes up more than half of energy supply, it's only around 25% in Germany. Denmark shows that this change is possible, even without major restrictions on demand.
The green transition that is necessary is not about how can we go back to the Stone Age or anything. The green transition is the possibility to make new lives, new way of living that could be a lot better.
How can we completely transition to renewable energies? What will that mean for society? These are some of the questions that the Potsdam Institute for Climate Impact Research is addressing.
We need many different technologies, and in high quantities, because of our failure to enact climate policies over the past 15 years.
It is very important to understand how huge the challenge is. Some years ago we were discussing that if we don't do anything, then we will have the big climate change, and that would be terrible. Now we have to say, it's not something that will come in the future, it's here now.
If we are to achieve sustainable climate policy, we'll need renewable energy. In 2022, for the first time, there was as much money invested into renewable energy as into fossil fuels. The majority of Europe's new wind turbines are currently in the North Sea, off the coasts of Germany and England. In a few years, the power generated is set to be able to supply half of the EU's population. Just a few years ago, these sorts of magnitudes were barely imaginable, but things have changed, a development which also benefits German wind farm operators.
Offshore wind was an asset class everyone used to laugh about. A few wind turbines offshore in the German North Sea or the UK. Today that has completely changed. It's the backbone of our energy transition, rivaling large power plants. Our offshore wind farms are comparable to coal-fired plants, even nuclear plants.
The North Sea, but also the Baltic Sea, holds fantastic potential, especially for offshore wind.
It's
a huge expanse of ocean, with potential to build 300 gigawatts there.
300 gigawatts of power from the wind farms in Europe's northern seas alone, equivalent to over 200 nuclear power plants. It could supply up to 300 million households, a tenfold increase over its current output. Germany's power grid operators are also preparing for the shift.
I think everyone's realised the Baltic Sea and North Sea are the places we'll most likely be able to generate our future energy reliably. With so many countries enthusiastic about it and so many industry representatives on board, I think the consensus is that it really has begun.
The world's largest wind turbine test center is located in Ørsted, off the western coast of Denmark. Here, they're looking into how to improve the stability and efficiency of the turbines. They're to withstand the forces of nature for 20 to 25 years in climatic conditions that were considered untenable just a few years ago.
day it's super calm, but you also see the really rough wind, what it can do, and how these structures play with nature. So when it's really windy, you can really hear that the wind is pulling in the blades.
As a wind turbine's output increases, so does its cost effectiveness. Increased efficiency ultimately impacts the price of electricity for end consumers, both for households and for industry.
We started here in Østerild 10 years ago with a much smaller turbine that was 6 megawatts in size. And I think it never becomes routine because every year, every 2 years, we expand the turbine sizes significantly.
Even when the wind isn't blowing, the pace of the EU's transition to climate neutrality is determined by the speed of adoption of greener energies. Northern European countries will need a considerable amount of wind turbines as they build out their networks on sea and land. It's why Esbjerg, Denmark, has built Europe's largest shipping hub for wind turbines. In just a few years, all of these here will be supplying electricity, also to new industrial centers that are being built along the new energy network.
I believe we'll see industrial companies' new investments and locations aligning with where energy is particularly green and where it's particularly cheap. I think there's a close connection between transformations in energy systems and future industrial policy.
The International Renewable Energy Agency has also noted a correlation between sustainable energy supplies and economic upturn.
Transitioning to renewable energy is the project of the century. It means rebuilding our industrial structures. IRENA is predicting a 380 gigawatt target for 2030 and even 2,000 gigawatts by 2050.
Those are global targets. 2,000 gigawatts is enough to provide a fifth of humanity with power. The progress, especially where wind energy is concerned, is astonishing. Nevertheless, the pace of expansion would have to pick up significantly to hit that self-imposed target, and prices would need to continue to fall.
Was uns Hoffnung machen kann, ist, dass wir
We've had a few extremely inspiring developments in technology. With photovoltaics, we've seen that the cost of energy being generated by new plants has fallen by a factor of 10 between 2010 and 2020. That's breathtaking.
Zwischen 2010 und 2020. Das ist atemberaubend.
The second pillar of the energy transition is solar power. It too has seen rapid technical advances. The first solar power plants used thermal heat to generate power. Mirrors focus solar radiation onto a tower, generating temperatures of up to 1,000 degrees Celsius. Minerals such as salt are melted. They store the heat, which can then be used to power turbines and generate electricity at night or in bad weather. They're known as concentrated solar plants. Initially expensive to operate, they are now experiencing a technical and economic renaissance. In Madrid, José Luis Adanero works for a major Spanish technology group, analyzing investment opportunities in renewable energies.
Luego, desde el punto de vista de tecnología, pues tratamos de estar en la vanguardia.
From a technological perspective, we're striving to be at the forefront by using the latest solar panel models and technologies, like bifacial panels, or finding out the best way to optimize our inverters, and things like that. The prospects for growth in photovoltaics in Spain are incredibly promising. All of the necessary conditions are here. Plenty of land, solar energy, a well-connected infrastructure, and motivated supporters who are actively developing projects.
Spain has invested extensively into new solar plants. Now, in its sunniest regions, the country enjoys very low production costs for solar power when compared to many other parts of Europe. The constant advances in technology are now also leading to smaller systems with decentralized applications. The concentrated solar process remains essentially the same. Mirrors focus the sunlight, directing it onto a storage medium. In this system, water in a drainage system is heated. The steam drives a turbine, which in turn generates electricity that's fed into the grid. If the Spanish and the North Sea region's existing capabilities were utilized optimally, they, with the help of the sun and wind, could cover much of EU's energy requirements, something becoming more and more possible with the falling costs of renewable energy.
Und wenn man das jetzt zusammennimmt, sieht man, dass wir
Add that all up, and you can see that we're well on our way to a system that's not based on fossil fuels, but on renewables.
basierendes Energiesystem.
The fundamentals are there, but the question remains, how do we scale it all up in time, before the worst-case climate catastrophe occurs?
Dass sie rechtzeitig kommen, um die schlimmste Klimakatastrophe abzuwenden.
How do we scale up the building blocks for such a system? Scientists around the world are asking themselves the same question. In Berkeley, California, Professor Jian Lin, together with Beijing's Tsinghua University, is researching the influence energy generation has on climate change.
In the past, people typically assume going cleaner or greener in terms of your technology or economy is going to cost you more. It's no longer the case. In China as elsewhere, renewable energy is becoming lower cost solution than fossil fuel.
In China, too, developments in sustainable energy generation are seeing a rapid upswing. Industrial wastelands and areas no longer being farmed are turning into gigantic solar farms. Around 80% of the country's rising energy needs are still met by fossil fuels, but that's set to change. China wants to double its solar and wind power capacity by 2030. This would place the large country alongside the European Union as a global leader in the transition.
We're predicting that 60% of global investment into energy transition will happen in Asia, and 40% of that's in China.
It takes sort of a coordination on a massive scale. There's still a lot of so-called bump in the road as you transition so completely to a carbon neutral economy. But climate change is a global challenge that would require global collective actions from all sectors of the world, both public and private, both industry, government, and citizens.
Large solar parks are being built on the water and in the mountains, too. And infrastructure is also coming along. High-capacity power lines that carry electricity to where the world's second-largest economy needs it most, in its industrial centers and large megacities.
In our analysis, we have demonstrated that as clean energy becomes cheaper than the traditional fossil fuel energy, you're going to save money for consumers and manufacturers. The money saved can be recycled through the economy, investment in consumption, that will lead to higher level economic growth and more jobs.
A new solar plant is currently under construction in the Tanga Desert. It's set to become one of the largest in the world, supplying more than 2 million households with electricity. Projects of this magnitude don't only directly impact China's energy industry.
Given the size of the Chinese economy, once it decides to move to a certain direction, it would affect the technology cost innovation process globally.
Decreasing costs and increasing efficiency. If the potential of solar and wind energy is harnessed consistently, a full transition could succeed on a global scale. Worldwide, researchers are currently hard at work on technologies to advance energy generation. In California's Silicon Valley, there's a special focus on materials research. The scientific community sees this as vital to the transition to renewable energies. The hope is to increase the efficiency of production, thus making it even more affordable. In order to achieve these goals, we need to understand on an atomic level how energy and matter interact. Stanford University is home to the world's largest linear particle accelerator. With this 3-kilometer-long machine, researchers want to find out how certain materials can absorb, store, and transmit energy with as little loss as possible. Professor Norbert Holtkamp played a key role in the machine's design. The German-American heads an international research group.
Kalifornien ist nicht das allgemeine Amerikas.
California isn't like the rest of America. California is in many ways a trailblazer. You see it here in our team as you walk around. There's a spectrum of nations, ideas and ways to approach things. It's great. We work very closely with several German institutions, but also around the world, Europe, Japan and Korea, South Korea of course, and many other countries that come visit us to use our facilities here, collaborate with us, and come back again as guest researchers.
With this gigantic machine, around 3,000 researchers are hunting for the smallest particles of matter in order to understand how they affect certain materials and how those materials can be further improved.
Hier im Gebäude werden Elektronen beschleunigt.
In this building, electrons are accelerated, and then the kinetic energy is converted into X-ray pulses. Those X-ray pulses are extremely intensified, about 100 million times more intense than any other X-ray source. They're very short, and they're what we physicists call coherent, and scientists can use this light in materials research. There are very few lasers in the world like this one. This one was first demonstrated here in 2009 to show that something like this does in fact work, and then suddenly, within 10 years, there are 7 more of them in the world.
In 2009, it was proven that a laser shot at matter over a very long distance leaves a measurable mark at an atomic level. Institutes and laboratories conducting basic research in these areas have sprung up alongside the Stanford Particle Accelerator. This is where the materials are created that will one day help with our energy needs. Steve Eglash leads one of these laboratories.
In this lab, we develop new materials and chemistries for batteries, new architectures for putting batteries together. We develop scalable processes for manufacturing those materials at large scale for the world's energy transition, and we make small batteries that we can actually test and use in real operating conditions.
Battery technology is currently developing much like the way microchips have, becoming increasingly smaller and more powerful. Without chips, modern life would be wholly inconceivable. The same goes for batteries too. They are necessary for the transition away from fossil fuels. Yet they're still too heavy and too expensive for many applications. A race in global research has been happening in this field too.
Es ist in der Tat richtig, dass viele Materialien,
It is indeed true that in order to truly usher in this new era, new materials will need to be tailor-made to specific uses.
auf ihre Anwendung zugeschnitten sind. Eben die Möglichkeit,
To have the possibility to assemble materials like Lego bricks, just as you want them. It's a big challenge, of course, and lots of people are working on it. If it's successful, it will have a huge impact.
Mit enormen Auswirkungen, wenn es erfolgreich ist.
8,500 kilometers away from Stanford, in Copenhagen, Thijs Vega heads a global research group at the Technical University of Denmark. It compares worldwide scientific findings and makes them available to researchers.
A key concept in what we're doing is developing what's called materials acceleration platforms. And they are, you can think of them as scientific Lego blocks that you can construct with Lego blocks in different colors from different countries to solve or to build the specific castle that you are interested in building. So it's, you can say, continuously operating around the world, 24/7, gathering the data that's needed, controlling experiments and equipment at other places. It's really a global challenge and a global solution.
Research so elaborate and complex that it would be inconceivable without international cooperation and exchange. Once a year, Berlin's Falling Walls Science Summit brings together leading experts. Scientists Vega and Holtkamp have also been invited. The hot topic at the moment is artificial intelligence. With the immense amounts of data from global research, AI could help find the most promising approaches faster than any human could.
AI-guided discovery is really key to what we do. But having the right players in the war room is actually essential. So yes, we can do a lot with artificial intelligence, but imagine that processing techniques that are required for that specific material do not scale. We need the input from the producers, the manufacturing industry, to get that integrated into the design process.
It's a gradual process, which sometimes, if you're lucky, can lead to giant steps forward in science. But this problem, of course, has to be solved globally. It's not enough to just solve one problem. If you want to make this a better world, you really have to tackle all of it.
Singapore is considered a major hub for research into future technologies. There's a high concentration of world-renowned universities in the small city-state. Many research institutions are collaborating with large, globally active companies on the advanced technologies of our time. The goal is to test research results, quickly identifying any applications for industrial mass production so that successes can hit the market as fast as possible.
Yeah, describing P1, P2, P3 line.
Professor Yi's Institute 2 is focusing on research into new semiconductor materials. They're used to convert solar energy into electrical energy. Particular attention is being paid here to a mineral called perovskite. Its special crystal structure ensures higher efficiency in solar cells.
So this is how we make a perovskite-based tandem solar cells. So this is our perovskite lab. This is the glove boxes, and because the perovskite is very sensitive to the moisture and also oxygen. And here in the glove box, we have a few 100% nitrogen atmosphere, and which allow us to make efficient and stable perovskite. And this solar cell contains two absorber layers. One is perovskite, and one is organic. And this device we sent to Japan, GET, and got a certified 23.4%, which is the world record for this type of solar cells. It's an interesting one. Yeah?
The higher the efficiency, the more electricity generated.
Here we mainly work on the solar cell research, and so we are kind of like a bridge between the university and the industry. And here we want to accelerate the transition from the lab and to the factory.
The National University of Singapore. It has a reputation comparable to that of Stanford in the US or Oxford in Britain. Here, interdisciplinary research is being conducted into future green technologies with a focus on solar power.
I think we should be optimistic. We just take solar energy as an example. 20 years ago versus now, the cost difference is a few hundred times difference. We never expect to be so cheap, so renewable, which it is. If we take the solar energy as an example, we started 20 years ago, few dollars per kilowatt, right? And over the years, through the continuous efforts of many researchers, and there's actually leap in terms of the science that we can expect. Now, actually, in some of the places in the world, it's only like a few cents per kilowatt.
something crucial for the future of solar energy. One of the leading centers for research in this field is the California Institute of Technology. Solar cells using new materials are developed here. Professor Harry Atwater researches their development.
When I began my work in solar energy, the world had less than 1 megawatt total across the entire world of solar power. We now have, as of last summer, more than 1 terawatt electric power generated by photovoltaics, so a million-fold growth.
That's just under a quarter of renewable energy sources' total output, but of course nowhere near enough for a complete global transition. It's estimated that 20 terawatts will be needed. To meet this goal, researchers like Atwater hope to keep improving their materials.
Material science is a platform for innovation for sustainable energy. It's a very, very powerful platform because almost all the renewable energy technologies that we are working on now, whether they be solar cells, fuel cells, batteries, electrochemical cells that make hydrogen or reduce CO2 and do all of the things that we're trying to do to build a sustainable energy economy, they all rely on materials.
Something being researched all around the globe. In order to move as quickly as possible, researchers need to work closer together than ever before.
Developers of new technologies, new materials, have fantastic equipment available, fantastic resources, experts in different domains, different places. But we need an infrastructure that supports that we can use that and exchange data to perform the experiments that are most essential to gather the missing piece of information that's needed to further the development of the new materials.
We need to discover new materials that have higher energy density for electricity storage, new materials that can produce higher solar to electric or solar to fuel conversion efficiency. We were able to achieve record efficiencies for generation of hydrogen from water splitting. That actually was a collaboration with the Technical University of Ilmenau in Germany.
Yet another example of successful international cooperation. On to Germany, to the Ilmenau University of Technology. The Thuringian Energy Research Institute here was founded with the aim of bringing individual areas of research together. Experiments to test the practical applications of research for industrial processes are carried out as quickly as possible. Together with his colleague Atwater from Pasadena, Professor Thomas Hanappel is conducting research into the components of the 21st century's most important resource, semiconductors. They can be as tiny as they are complex and made up of different layers of materials. To create perfect harmony within that layering, a mastery of basic materials is required to understand how they all work together. The goal here is to achieve the greatest efficiency possible.
You really have to understand things down to the atomic level to get the main components to ultimately run flawlessly.
The Ilmenau reactor can heat matter up to 1,000 degrees Celsius. At that temperature, materials can reach a perfect level of purity. Once the semiconductors are freed of impurities, they can be assembled, like a Lego set, and stacked in layers and studied. Doing so helps improve the efficiency of existing semiconductor materials and could allow for the creation of completely new materials.
Now you can basically see the actual reactor. Here's the sample, and here's where the gas comes in, flowing over the sample.
Here it takes another minute to reach its boiling point. Once the pressure in the reactor is also high enough, I can start the process.
The temperatures that we're now aiming for with this sample, what are they, Kai? Up to 1,000 degrees. The temperature is slowly rising.
Connecting such highly complex research to practical applications like this is unique. Reactors like the one in Ilmenau are also used in industry. Everything that's needed for swift implementation on a large scale is already on hand.
This combination is pretty original. Other locations may have comparable approaches, but the fact that we do this balancing act here, directly linking of science and industrial process, it is a solution which, I believe, is unique in the world.
Speed isn't everything, but it's highly important in the race to a greener future. For a long time, governments had other priorities. The focus was on the use of fossil fuels and research into nuclear energy.
What's happened really is that we lost another 15 years as global emissions continued to rise. We've also realized that the effects of climate change are much more dramatic than we thought 15 years ago. That in turn means we need to have even more aggressive climate targets. The speed of transformation needed to get from our current state to an emissions-neutral system needs to increase. The window has shrunk from 50 or 70 years to just 25.
That's why scientists are under pressure to deliver results that can quickly reach industrial maturity. Additional ideas are being pursued today that sound a bit like science fiction, like harnessing the power of the oceans or capturing solar energy in space. At the California Institute of Technology, the Space Solar Power Project is pursuing the bold plan of collecting solar energy directly, up where the Earth's atmosphere doesn't get in the way. From there, it could then be beamed to relay stations on Earth.
What is the white? We're demonstrating here today a couple of small-scale, very small-scale prototypes of the photovoltaic cells being designed for the Space Solar Power Project. The Space Solar Power Project is aimed at building the components of an ultralight, very large-scale solar power generation system in space. So every satellite in space nowadays uses solar panels to power its satellite operations. Typically, satellites are relatively compact structures. They're a few hundred kilograms at most. But what we're aiming to do with the Space Solar Power Project is develop scalable fabrication methods for building very large-scale power systems that could go to the megawatt and hundreds of megawatt scale in space, and which would allow us to wirelessly transmit the power back to the Earth and use it on Earth.
Even this experiment in space would not have been possible had it not been for the great leaps made in materials research. Photovoltaics have seen incredible breakthroughs.
Yeah, well, it turns out that the materials that are most suitable, in fact, are inspired from some of this work that we have done in photovoltaics and solar fuels, because they are semiconductor materials and insulating materials, the kinds of materials that we use in those other lines of research.
In January 2023, a prototype of a self-unfolding solar array was launched into space for the first time. With it, Professor Atwater's team hopes to see how feasible a future solar farm could be. Each one is expected to measure 3 kilometers by 3 kilometers, at least to start. The idea is to assemble several such elements into giant solar farms.
Well, the big advantage is that it is never nighttime in space. If you go far away from the Earth to a geostationary orbit and you point your solar collector at the sun, it is noon on a sunny day, 24 hours a day. And as a result, you generate on a day-night cycle basis much more solar power in space than you do on Earth.
In space, there is no limitation to neither sun nor size. The energy harvested could then be beamed to receiving stations on Earth in the form of electromagnetic waves.
Very much like the way your cell phone, your mobile phone works, where you transmit a signal from a antenna to your phone or from your phone to the base station, we can use the same frequency radiation to transmit power from space to the Earth.
A breakthrough was reported in March 2023. For the first time, the solar array prototype sent electricity back to Earth. So the technology works, in principle. It will be years, though, before it can be used in practice. At Stanford and around the world, researchers are thinking far ahead about making a full energy transition possible.
I would almost say we are racing towards what I'd call an energy revolution. That might sound dramatic at first, but it hints at our future prospects.
We need to get young people excited about STEM professions, about renewable energies, so that they join us as soon as possible. That has to happen. These fields have many jobs waiting for them. They just don't know it yet, and we need them.
Science and technological innovations have made tremendous progress in recent years. And in the major industrialized nations and around the world, the political will for transformation is there. But there is still a long way to go before green energy is powering everything on Earth.
We don't know yet how will it be in 20 or 30 years, but we have to start on it. And some of the decisions we take now, we know that maybe in 15, 20 years we will look back and say that was a wrong decision. But we have to try.
Today, not simply someday, actions need to be taken that bring us towards the sustainable energy of our future.